Lewis electron dot diagram for carbon tetrachloride, CCl4. First of all, I'm going to write down the atoms. Oh, just a minute. Draw. I'll use blue. CCl4. So carbon has a valency of 4. Chlorine has a valency of 7. Well, carbon with this valency of 4 wants to share 4 other electrons. It wants to bond to 4 other atoms. Chlorine, however, it's got a valency of 7. That does not mean that it wants to bond to 7 other atoms. That means it has 7 valence electrons in its outer shell, and it wants 1 more valence electron to have a complete shell. So each chlorine really only wants to share 1 other electron. So what I'm going to do is I'm going to start off with an electron tally, doing an electron tally for carbon tetrachloride. So in this molecule, I have there's 1 carbon atom and 4 chlorine atoms. Now, each carbon atom, if you look at a periodic table, brings 4 electrons for sharing. Each chlorine atom brings 7 valence electrons for sharing. So now I have to find an eraser and get rid of that. Just a minute. Eraser, small eraser. This isn't going very well. So I go back. 4 times 7. So that means I have carbon's bringing 4 valence electrons for sharing, and each chlorine is bringing 7 valence electrons. However, there are 4 chlorines. 4 times 7 is 28. Now, the total number of valence electrons that will be available for sharing between these atoms will be the sum of the valence electrons that carbon brings plus the sum of the valence electrons that all the chlorines bring. 4 plus 28 is 32. So there are 32 valence electrons. Now, I've made this symbol with an E. I've done a little E with a negative sign behind it. That symbol here, this symbol, I'm going to use that symbol to represent electrons. Those are electrons. So now, the next step in the process is to start off by taking the atom that appears first in the formula. And now the atom that appears first in the formula is almost always the central atom in our Lewis electron dot diagram, unless that first atom is hydrogen, and that's really the only exception. So I'm going to start off by putting the carbon in the middle, and I'm going to put the 4 chlorines around that carbon, like so. The next thing I'm going to do is I'm going to represent a chemical bond by the sharing of 2 electrons. So I'm going to put 2 electrons between each of these atoms. And I'm going to do the same thing like this. Okay, so now each of these chlorine atoms is sharing 2 electrons with the carbon, and the carbon's actually sharing a total of 8 electrons with each of the chlorines. What I'm going to do now, because it's going to get kind of messy if I just use dots all the time, I'm going to actually put a line connecting the dots. And the line will represent the sharing of a pair of electrons, which is a chemical bond. Now, I'm going to take a look at the chlorines. Now, each chlorine wants to have 8 valence electrons around it. This first chlorine here, let me get my highlighter. This chlorine sees 2 valence electrons, 1, 2. It wants to have 8. So what I need to do is I need to make it happy. So I'm going to actually just force it to have 8 electrons around it. So I'm going to just put another 6 dots around that chlorine. Now, this chlorine here on this side right here contains or is seeing 8 electrons, 8 valence electrons. So it's happy. I'm going to do the same thing for each of the other chlorines in this molecule. All right, so now all the chlorines are happy. They all have 8 valence electrons around them. What about the central atom, the carbon? Well, the carbon, it sees 2, 4, 6, 8 valence electrons. Okay, the carbon seems to be happy. There's a very important step that we have to do, the final step in this process. We have to make sure that we actually distributed the correct number of valence electrons. Recall that there were 32 valence electrons to distribute. Now, in our structure, our Lewis electron dot diagram, we can't have more than 32 electrons. We can't have less than 32 electrons. So what I'm going to do is I'm just going to count up. How many do we have here? Oh, now starting here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 32. We have 32 electron dots in our Lewis electron dot diagram. And we have 32 electrons, valence electrons to distribute. So it is a happy Lewis electron dot diagram. Next.